There are a lot of adages and guidelines that help us write high-quality code. The most well-known of these is called the principle of information hiding.
Oh, good. You're going to go off on some touchy-feely tangent instead of teaching us more Java.
You're right, Jejun. Here we go. The general philosophy of the principle of information hiding is that we should restrict access to variables and methods as much as possible. We can achieve that using modifiers in the declarations of our instance variables and our methods. The modifier public means that the whole system can see the thing that's being declared.
In other languages, those variables that all of the code can see are called global variables, and they are really risky.
That's true. When a variable is global, that means that any code in the system can change its value.
As long as we all write our code carefully, who cares?
Jejun, sometimes it's good to learn from people with more experience than you. Check out what these experts are saying about them. Those are some pretty strong statements. Having a lot of global variables has been linked to some really terrible bugs, including the unintended acceleration of Toyotas that killed people. In fact, there's a standard for building safety-critical systems called MISRA. This standard was originally developed for cars, but it has been broadly applied. One of the things MISRA talks about is how different components, in our case components are classes, how different components interact with each other. In that list, they put global variables as the second to worst kind of relationship. The reason that global variables are so bad is that different parts of the system might understand the purpose of the variable differently. As the system gets more complicated and we're adding to an existing system, it's easy for an engineer to misunderstand code that someone else wrote. If that happens, when the system is running, it almost looks like the value of the variable just randomly changes. Trying to find out who used it wrong requires looking through the entire system. That makes those kinds of bugs really hard to find. At the other end of the spectrum from the public modifier is marking things as private. When we use private as the visibility modifier, only the code in that one source file can see the thing that we're declaring. As a general rule, all instance variables should be made private, and only methods that some other part of the system needs access to should be marked public. Whenever possible, things should be marked private.
In truth, there are two other visibility modifiers, but they relate to parts of Java that we won't see in this course. You should learn about them when your systems become more complex.
Since we want to make all of our instance variables private, we often need to provide a way for others to view or modify them. To do that, we make methods that provide that access. Getters are methods that simply return a value, and setters are methods whose purpose is to set that value. When we do this, we make the method be named get or set, followed by the name of the variable, getBalance and setBalance. If the variable is Boolean, sometimes people use is instead of get, isAlive instead of getAlive.
You need an example.
I'm on it. Here's a simple class that has one instance variable. We marked it private to keep it hidden. This is its getter. Notice that the name is get plus the name of the instance variable. Its return type matches the type of the variable, and it only contains the return statement. This is the variable setter. The name is set plus the name of the instance variable. The return type is void because it doesn't return anything. It has one parameter whose type matches the type of the variable, and all it does is copy the parameter's value into the instance variable.
OMG, you have gone off the deep end. That is a lot of work for one little variable.
Oh, Jejun, things are only hard when you don't know how to do them. Eclipse has a bunch of tools that help us write standard types of code like that. So here is my simple class, and it has its instance variable. If I say select it and say source, generate getters and setters, it lets me pick which ones I want, and I say generate. Lo and behold, it writes the code. Now, the code that it's written here is just a little bit different from the code that was in my example. You'll see it uses this keyword this. The trouble here is, and we'll talk about this a lot more next chapter, but it created two variables that are named instance variable. One of them really is my instance variable, and the other one is the parameter to the setter. When you do that, using the keyword this says use the one that is the instance variable. And when you don't have the keyword yet this, it says use the one that is the local variable. But I don't really like this code because I think it's confusing that there are two variables of the same name. Eclipse can help me fix that as well. If I select a variable and I right-click and say refactor, refactor means mechanically fix my code in a specified way. So I say refactor, rename the variable, and change it to val, and hit enter. It changes the name of that variable everywhere that it's used. So now this is val instead of instance variable. And now, since I don't have two variables of the same name, I don't need the keyword this. This code is my example code. The advantage of creating that setter is that it is a gatekeeper that protects our variable. Since our variable is private, no code outside our class can see or change it. So the setter is the only place where code from the outside of our class can come to change the value. That means that a single breakpoint in the setter catches anyone who tries to change the value. The bottom line is that the principle of information hiding says to limit the part of the system that has access to variables and methods as much as possible. In Java, we do this using visibility modifiers. The convention is to mark all instance variables and as many methods as possible as private. We use getters and setters to provide controlled access to the instance variables. The purpose of this is to limit the way our classes interact because that reduces bugs. And when bugs do happen, the controlled access makes them much easier to catch.